This video is going to go over how to model equations. So we're going to draw pictures to represent the variables and constant numbers. We're going to start on page 18 of your journal for those of you who are in my class. A couple things on modeling equations. Equations will have something, a letter known as a variable, and then also constant numbers. So you can choose on your own how you want to model your equation. You can pick different shapes to represent a variable and then a second shape to represent the constant. So you could have squares and rectangles, you could have triangles and circles. It's pretty endless. But then also we have to distinguish between positive and negative numbers as well. So you might decide to shade one of them and not shade the other, or you might just choose to put a plus sign and a minus sign to represent positive and negative. So this first example, there's a rectangle representing the variable. Then there's 3 little squares representing this constant number. Now on the opposite side of the equation, we have to use the same symbol to represent the other constant number. In the bottom, there are 3, these are supposed to be cups to represent the variable, and they placed an X on top of the cup. So you know there's 3 X's, that these represent the variable. Then these little circles, it's a little hard to tell, but they have plus signs in them. If I zoom in and on your own journal page, you can tell hopefully that these have plus signs. So these are all positive numbers. There's positive 4 to represent this constant number. And then there's 13 of the same shape with positive signs to represent this constant number at the end of the equation. So we're going to model a couple of equations together. We're not going to do all of them. I'm going to ask you to write the word skip in this one because we're only going to do one in this section. I'm going to push this up. I am going to use the rectangles and squares to represent. So this is my constant number because there's no variable with it. This is also a constant number. And then the one with the letter X, this is my variable. And we're not going to solve it, we're just going to draw it today. Okay, so I can use whatever color I want. I can just use black. I'm going to use boxes to be my constant number. So the first one, I'm going to also put my equal sign in there to distinguish the left and right side. On the left side, I have a constant number of 6, so I'm going to draw 6 boxes. And they're positive, so I'm going to put the positive sign in. Then the second part, it says minus 2x. So I'm not going to draw a minus sign. I am going to make this minus sign, pretend like it goes with the 2, and represent it as saying negative 2 shapes for the variable. I'm going to use rectangles for that. You can use the same color or you can switch. It doesn't matter. I'm going to have rectangles. And I'm going to put negative x, and then I'm going to draw another one and put negative x. If I had to do these on my own, this is how I would do it. Then I have the equal sign, so I've drawn an equal sign. Then I have another constant number, which was negative 4, so I have to use this same shape, but because this was negative, I just need to draw negative signs in there. So since I used pink, I'm going to use pink for the squares again. But I'm going to have to put the negative sign in the middle so that it represents what the equation is saying. And then that's how I would model the equation that's on the left. On this page, this is a little bit different version of modeling. So we have the top row would be like the left side, and then it equals the bottom row. You can tell that the this row is the total because it's the entire bar. So I'm going to say it equals 8. And then the top row, there's 1x. So you can literally put the 1 or you can just write x. It's up to you. And then the 3 is all by itself. So that must mean it's a positive 3. And that's how you would write the equation for that one. The second one underneath, the top row, again, would be like the left side of the equation. The bottom row would be the total, or the right side of the equation. So I'm going to label this bottom one as the total again and put it at the end. Then when you look at the top row, this time they had negative x and negative x. There's 2 of them. So I'm just going to write them together and say negative 2x. And then the 6 is all alone. It doesn't have any kind of negative sign with it, so I'm going to represent it by writing positive 6 or add 6. And that's how you would write the equation for the model that's already given. So on this last one, I'm also going to ask you to write skip on one of them. We're going to skip the bottom one this time. So I'm just going to zoom into the top. The thing that's different about this one is there's a variable and a constant on the left side and a variable and a constant on the right side. So I'm just going to label those. So I have a variable right here. And I have another variable. And then on top, I have my constant number from the left. And I have another constant number on the right. And we are going to put those add and subtract signs with that number 3. I'm going to separate my box with my equal sign. So on the left side, it says positive 2x. I'm just going to represent the same way with the rectangles again. Let's scoot this over just a little bit so you can see better. Positive 2x. This time I'm going to use pink for the variables, which is fine because I'm doing a separate model. And then it says minus 3. So instead of me drawing a minus sign, I am going to make this minus sign be represented by drawing them inside the little shapes for the 3. So I'm going to draw little squares and put a minus sign in. And now I have my left side. On the right side, there's just 1x, and then it says plus 2. So when I draw my constant, I'm going to put plus signs inside of it. So this, on the right side, I just need one shape for the variable, and it was positive x. And I need 2 constant shapes, and they were positive, so I'm going to put a plus sign in between. And that's how you would model that equation.